In this video, we'll discuss amplitude, the amplitude of a wave. We'll only be talking about transverse waves. Amplitude really only applies to transverse waves, at least in this course. So it's pretty clear that if the height of the wave is what amplitude is, then this wave here has a greater amplitude than that wave there. And it's not a lot more complex than that. There's not a whole lot more to say. One thing, though, we need to say is that height is measured from the center line to a crest or center line to a trough. Here's your video code, T. Krug. T. Krug. The reason I mention that is because sometimes people will think that amplitude is measured from, say, the hole from a trough to a crest. So you can go that little line there, and that maybe that's your amplitude, but that's not true. Not true at all. So it's really from the center line to a crest or to a trough, not the whole distance. Now, the last thing I want to say is that sometimes if people can look at a large amplitude wave compared to a small amplitude wave and think it also has a greater frequency, but this wave goes up and down faster. Let's see. Wave A obviously has a larger amplitude, obviously much larger than that one. But what about frequency? Many would say that A has a larger frequency too. But does it? Well, I'm going to copy that picture here and show you something. If I draw lines from the crest here to the crest here and the troughs, notice how they all line up. So these waves have the same frequency. Does wave A have a larger frequency than B? No. The crests and troughs align. So what happens here then is that the amplitude of A is larger than the amplitude of B. That's obvious, much larger. But the frequencies are the same. The large amplitude can fool you, so be careful. That's about it for amplitude. Measure from in a transverse wave, measure from the center line to the crest or a center line to a trough. And that's about it. Bye.